Okay. If we have a function f of x equals b to the x, where b is greater than 0 and not equal to 1, this function is going to be called an exponential function with base b. Okay. So the way that we get our outputs is we take our input, x, and we're going to take b to the x power. Okay. This x is called our exponent. Okay. So in this case, all of our inputs are going up into the exponent, and we will have a fixed base. Okay. A couple of notes about exponents. So b to the 0 is going to be equal to 1 for any b. If you have negative exponents, remember that this means the same thing as 1 over your base to a positive exponent. If you see fractions like b to the 1/2, this means the 1/2 root, or the second root. Okay. So the important thing here is that our inputs go upstairs in the exponent. So here are some examples of some exponential functions. We have 2 to the x, g of x is 3 to the x, and h of x equals 10 to the x. And we're going to compute a couple of these guys. So we're going to be working with 10 to the x. Let's look at some values. So we have h of -2. This is going to be 10 to the -2, which means 1 over 10 squared. And remember, when we're taking powers like this, this means 1 over 10 times 10, or 1 over 100. Written as a decimal, this is 0.01. Yeah, so maybe I should also add this note that if you have something like b squared, this means b times b. It's not the same thing as 2 times b. So the exponent is telling us how many copies of the base we need to multiply together. If we look at h of -1, this is 10 to the -1, which is 1 over 10 to the 1, or 1/10. And written as a decimal, this is 0.1. If we have h of 0, this is 10 to the 0th. And always, this is just going to be equal to 1. Any base to the 0th power gives us 1. h of 1, that input goes up into the exponent. So we have 10 to the 1, or just one copy of 10 multiplied by itself. If we add h of 2, this is 10 squared, or 10 times 10. This is 100. And if we have h of 3, this is 10 cubed, or 10 times 10 times 10. This is 1,000. If we build just a quick graph of this, graphing exponential functions can be pretty tough because as part of our graph is going to have very small values. Part of our graph is going to have very big values. So, on our normal set of axes, it can be very difficult to show enough detail either where it's small or where it's big. Okay, but we will do our best to get a nice general impression of what's going on here. So, well, we are going to be off this chart very quickly. Okay, so let's see. We know that h at 0 is equal to 1. H at -1 is 0.1. H at -2 is 0.01. So that's very, very close to 0. Quite small. H of 1 is 10. So that's like all the way up here. It's huge. And so this is kind of a characteristic shape of our exponent graphs. A couple of things we can note here. The domain is going to be all real numbers. So it's easy for us to see how we could put whole numbers in. But it's also possible to graph any fractional power. And basically, we'll just fill in all of the other points. Once we have the fractional powers this gives us the whole graph. Okay. And then the range. I'd like you to take a look at this graph for a good long minute. So if we look at positive inputs where x is greater than 0, we're taking powers of 10. Okay, so these are all positive. When we take when we have negative inputs, we're taking 1 over 10 to some power. And so this is still positive. It's fractional, it's going to be a value that's less than 1, but it's still positive. So our range here is 0 to infinity. Okay. There's no way to produce negative values here. And so this is one place where it's really important to kind of keep track in your head that when we have a negative in our exponent, it means 1 over, but that negative doesn't come down in front in any way. Okay. So next up, we're going to look at some rules for working with exponents.